Hi, and welcome to this introduction series of films called Curious About Graphene.
If you want to know about twistronics, Hofstadter butterflies, that's really good. It's really cool. It's really interesting stuff. But then this course is not for you. Then we instead recommend that you find a university you like and see what courses they have in this subject. Here, instead, we want to focus more on the possibilities with graphene, a little bit about the development. Where are we now and what can be done?
And graphene, as you may know, is a true super material. It's a single layer of carbon atoms in a hexagon pattern, and it's the world's thinnest material. I mean, if you have 150,000 layers of graphene, it will add up to one single hair stray. Yet it's stronger than steel and flexible and transparent and conductive and light and stretchable and impermeable, and I could go on. It's an amazing 2D material that is really multifunctional. And with all these stunning properties, there must be many cool applications. Could you give us some examples?
Yeah, of course. So there are many things, exactly as you say, that where this has potential, and it can be used as an additive in many different materials. This can, for example, be to enhance mechanical properties or to add new functionality. So, for example, thermal or electrical conductivity. It can be used in polymers, in metals, both using traditional production methods or, for example, additive manufacturing. Many of the existing products today are in the sports industry, where lighter or stiffer materials can really make a big impact. Or actually simply like making materials with higher impact resistance, which can be very important in some sports, so you don't miss an opportunity or a very good goal scoring opportunity because your stick breaks. It could also enhance batteries or make completely new different types of energy storage systems. 2D materials can be great in sensors, make new exciting wearables, and here's another really nice application using graphene. Any guess what this is used for?
This seems like some kind of textile, right?
It is.
Fabric. And it's graphene in it, I guess?
It is. And so the cool thing here is that the graphene is used basically to make a heater, so that you can send a small current through the graphene, and just by resistive heating it becomes warm, and you can put this in clothing so that you stay warm in the Swedish winters.
Oh, cool. And is it made in Sweden?
It is by a company in Linköping called Graphene.
Oh, nice.
It's really useful. This is actually one of the really cool applications as well using graphene.
What is this? It looks like cardboard?
Yeah, exactly.
And is it graphene in it?
Yeah.
And what's the key element of it? Is it stronger than steel, or is it harder than diamond?
No, it's not a really smart use of graphene. Mm-hmm. So the properties of the cardboard itself is more or less the same as any cardboard, but thanks to that it's being used in here, so the production process is much better. So this can be made 30% faster and using much less energy when you do it.
So it's in the adhesives, right?
Yeah, exactly.
Oh. Where is it made?
It's made in Italy and with graphene from a Swedish producer, so 2D Fab.
Cool. Well, isn't it amazing that with all these applications and possibilities with just one material?
Well, yeah, that is kind of true, but it's not really just one material. Or the way that we typically, or that most people use the word graphene, it's actually more of a family of materials than one specific. So as you can see here, it's basically down to the production methods. So you can either use top-down approaches, where you have graphite and make it thinner and thinner and thinner, until you get a thin layer of graphene. Or you go bottom-up and you basically build up the material atom by atom. So this gives rise to these different types of material. And the top-down methods typically gives you flakes, which can be used mainly in as an additive in many different materials. Whereas the bottom-up approaches more typically results in different types of films, often used in electronics.
Interesting. I mean, so many applications are made of flakes or different types of graphene. Could you describe the difference between graphene and graphene oxide a bit more?
Certainly. So graphene oxide, well, first of all, the two different materials are produced in different methods, which we will come back to in a later episode. But the properties are also different. So for example, graphene is dispersible in solvents, whereas graphene oxide is dispersible in water. And that makes a really big difference when you try to handle the material. Graphene also generally has better intrinsic properties, so better electronic properties, mechanical, and thermal conductivity and so on, for example. However, graphene oxide, it has on one hand some defects in the structure, that's why it doesn't have as good intrinsic properties, but these can also be used to combine it better with other materials. So it can be easier or can be better to put into polymers sometimes, for example. It can also be turned into reduced graphene oxide with properties somewhere in between. And that's also why then these two materials can kind of be thought of as that graphene with all the better intrinsic properties is a bit the dream material for a physicist, whereas graphene oxide that you can add functionality to and combine with other materials, it's more a dream material for a chemist.
Great. This is so interesting. And before we do a short summary of what you just heard about this lovely material, I want to mention other episodes that are coming up in this introduction series that we're doing, Curious About Graphene. So next up we will do about manufacturing, and we will go to Sundsvall and visit a real up and running factory that makes graphene in Sweden today. And we will also do other applications, or show other applications like electronics and energy and biotech, and also health aspects and standardization and other important stuff that's going on in Sweden today. But now let's sum things up.
So the main points to remember from today is that graphene really is an amazing material. It has many fantastic properties and can be used in many different places. There are also many different types of graphene that can also have different application areas. And it's not only graphene, but there are other types of 2D materials as well, which we will get back to more in a later episode. And there are also more and more products on the market, so it already has been used in many different places and in many different industries. And even more is coming.